All right, Hurt. I hope I said your name right. I have to confess that when I read your name for the first time, I actually misplaced the R at the start and I read it as Greet. Then I put your name in one of the pronunciation softwares, and then that actually said that your name was Geert, because there's a double E at the start. But then today, when I spoke to you at the start, you actually mentioned that your name is Hurt with a soft H. Did I say it right this time?
Yeah, Geert. Dus
Geert.
long E, that is correct. Greet is a female first name. So no, don't call me Greet, of course, but Geert, the soft way to say the name.
I'm going to grow into it as we progress through the podcast. So this is Power Query Battle Streak. You have been a fantastic editor, a technical editor of my book. Thank you for that. And I think there could not have been a better person than you. For the little chit chats that we put in the comments against one another comments, that was interesting to take a look at. And also your opinions on how to structure the book, how to make it more hilarious, how to make it more readable, enjoyable. All of that came in very, very handy and was very, very helpful. Thank you for that. Okay, so quick rules of the game here. We are going to play a Power Query Battle Streak. You've got 7 attempts to show the best of the tricks that you've got, and I've got 7 attempts to show the best of the tricks that I have got. And after every trick, the audience is going to rate us and say that whose trick did they like it better. They will give a point in the comments, and then let's just see who accumulates more points at the end of the show. And you've mentioned that you like Tintin, so we will actually decorate you in a Tintin character, and then let's just see Tintin versus Superman. Superman is what I like. Let's just see who wins in the end. Let the games begin. Are you ready?
Yeah, sure.
Awesome. So you can start your screen, and then we will roll.
So I see this video, Chandeep, as a celebration to celebrate our mutual interest and love for Power Query, M-Code, and sharing knowledge. Yeah? You share a lot of knowledge on your channel and in your work, and we like to do that. Now, I'm sure I just looked it up right prior to the call. I'm sure we all read the books by Ken Pulse and Miguel Escobar, right? And then I remember even their updated version was it's already some years back. So that shows how time flies. But I remember in the books by Ken Pulse and Miguel Escobar, in their book they mentioned if you want to merge tables, then you could use a little bit of M-Code, you write your own, but you should use the big gun functions like table nested join and things like that, because they said those functions are optimized to do the job. But you know what? Your book is about writing your own M-Code.
That's right.
I read the book by Ken Pulse and Miguel Escobar back then too, and I understand they said it's optimized and all that, so I'll add in a little step for optimization myself. I'm going to use case here from a real tool from work, and I kept the framework and the titles are in Dutch, being Flemish myself, and I may have to translate a few terms on the go very quickly, very easily. And don't worry, I randomized the data. Okay, I really went to town on randomizing stuff. I broke 3/4 of the queries, but the stuff that needs to work still works.
Cool. Let's
all right. Now, this tool, I'm going to write my own M code for doing an exact match lookup. All right. Okay. So it's really rock bottom is where we start. Okay. Now, this is a bit of a context. The intention is to make this blue table. Now, the green table here to the left, I collapsed it. It's a little bit bigger than what you see, but we're going to focus on the blue table. So there's a lot of stuff that I need to do. We focus on one of those tables. And I have 2 dimension tables, DOV and DML. And this blue table needs to be generated in a fully automated fashion. And I can lean on those dimension tables. I can derive it from DML, as a matter of fact, as you might expect. There's one column I need to look up in the higher dimension table. Okay. DOV is the higher dimension table. DML is the lower dimension table. So I'm going to do an exact match lookup. It's this column right there called entiteit, which means entity, and the name of the entity, like Zog and other crazy stuff that you see right now. And that's the exact match lookup. So I'm going to dive into that. A few steps which are preparatory, and we can glance over them. And then the trick is 2 steps. This is the one. So I go into Power Query and I go to the blue table, so to speak. We're going to create it, at least the first part. We're going to do an exact match lookup. So like I said, I can derive this blue table from the DML table. So the first thing I do, I load my DML table. I prefer indeed to change the types like the big guys taught us in their books. And so I have a list for that right there. I apply it and done. That is not part of the trick. It's just building up to it. One more such step. It's a big table and there's more than 50 columns. I want to restrict it to what I need. So keep relevant columns. I have a list for that as well. So somewhere down the line of these tricks is a Chandeep trick, of course, twist. So I have a list for what I want to keep. I apply that list and I'm good to go for my trick. 2 steps, the 2 following following steps is the trick. So if I want to do an exact match lookup, it is good to, if I want to do it using M code, the higher dimension table, the lookup table, I'm going to buffer it, hence DOV buff. I call that table, it's called DOV native because I have the other one as well, but not so relevant for now. So I call that higher dimension table, and all I do here is I buffer it. This is the optimization step. And then there's only one step left in the trick. Get entität, get entity, all right? And here it is. Zooming in, we can still see it on one line. I start from keep relevant columns, of course, my DML derivative. I say table add column by the name of entity. Keep relevant columns is the outer table. So what is the inner table? DOV buff, of course. And what I do is an exact match row lookup right there. And then I take the entity, declare type text, and done. Quick question to you, Chandeep. You see this thing here, OVNR equals OVNR. Now, two things. Why did I buffer the inner table? That is important because if you have an internal table and you want to speed up performance, try buffering the inner table. Okay, that is the moral. Now we have this thing here. Yeah, I'm going to highlight a small part here. So curly brackets is for rows. And we're going to do a relative formula here based on a column, hence the square brackets, OVNR. So there better be a column that goes by the name of OVNR in DOV buff. Not to worry, there is. Yeah? Otherwise, this entire query would break. Yeah? There are different kinds of errors. I read that in a book somewhere. These criteria statements in Power Query, this is the one. I selected all the necessary characters. They are not the same in Power Query as they are in Excel formulas or in DAX. I mean, we have an equal sign, and that makes us having a left-hand side and a right-hand side. In Power Query, you cannot flip them around. Why? Because the left-hand side is always interpreted as the name of a column here, the name of a field. Whereas the right-hand side is an expression. It's not the name of a column. I mean, it's different. Yeah? In this case, the expression is just a reference. Square brackets again, which makes it suspicious or not. OVNR. Now, these square brackets, they mean, in an expression, it means current row OVNR. In Excel table formula nomenclature, there would be an @ symbol. We don't have that here. Yeah, that's normal. Now, when you say current row OVNR, Chandeep, I'm not going to ask questions all the time, but current row with respect to what? If you were to say...
With respect to the table at the moment that we're working inside.
So if you were to say, or your viewers would think it's the current row in DOV buff, they would be wrong. That is not so. Yeah. When you see the square brackets there, current row, you're going to have to start looking to the left and find the first each keyword that you find. There's only one here. This each keyword defines the context with respect to which the current row is calculated. But that each keyword iterates over the outer table. It's a very simple formula, but explaining it in detail, I think, helps the people to create the insight to understand it. Yeah. So I hope you can appreciate what I've done here. Super simple, of course. Yeah. But I connected a table, a column on the inner table. With this expression, I connected it to something equivalent on the outer table. And I could do it in another way. I could put in another each keyword, say table select rows. Then I could have multiple matches. Table select rows, DOV buff, each, and have a second each. But then I would need to connect the inner and outer table. Oh, that's so complicated. This is much easier. By doing an exact match row lookup in DOV buff, I actually eliminate the use of one each instance of the each keyword, and I link it directly to the outer table. So it's a very nifty little formula, and all that logic is behind a very short notation, actually. I kind of like that. All right. So that is the first of 7 tricks, as you said. I'm going to stop it right there. Now, what do you think? Of course, you're going to show your trick, but what do you think about this? Buffering an inner table and writing your own matching condition. Do you think that is useful?
It's very useful. In fact, we have it in the book as well, where we are trying to match using the group rows operation. We are trying to match the inner table with the outer table, which is a very, very similar application. And I just want to give 2 caveats here to the viewers who are listening. One is that the buffer table needs to have the unique value in the OVNR column. That's one. That's really, really, otherwise this lookup operator is going to fail, and it said that we cannot find a single match. And the each keyword within the curly brackets is rendering a record, and from the record, Hearth is extracting one of the columns, which is the entity column. And then that actually lands up with one single value that is then converted into a text.
Yes, so that's this little part.
That is a beautiful formula.
All right, so I'm going to leave it for my friend. It's a very basic thing, of course. Yeah? It may be, I'm going to quote from a movie there, Casablanca, maybe the beginning of a beautiful friendship, because this may grow into something else. That is called foreshadowing.
For the tricks, let me actually share my screen and present my trick. All right, I've got a very simple table with a bunch of columns. We have date, sales rep, customer, amount, a profit, and the region. And this trick is like a togetherness of two tricks together. A lot of times people are going to use this particular option, which is remove other columns. So for instance, if I want to keep the sales rep column and if I want to keep the amount column, they are going to hold the control key, select these two columns. They're going to right click and say remove the rest of the columns and remove other columns. That's the option that they choose. And this creates a table. It's necessary to note that it creates a table, and the tables have the two names of the columns hard-coded right here and right here. Now, you can do the same thing with something called as projections. The reason why I'm choosing to use projections and my follow-on trick with that is something like this. So let's just say that between the two steps that we have created, which is the entire table and the columns that we have removed, if I happen to remove the column, which is sales rep, if I happen to delete this column, now you can see that this column is gone already, but this column is retained in the next step. So obviously in the next step, it's going to throw up an error that the sales rep column, sorry, was not found. So what can we do about it? This breaks the query. So let's just do it once again, but a bit differently this time. So I'm going to delete these two steps. This time I'm going to use projections. So I'm going to make a new step using the FX button. And the way projections work is that you reference the table, which is nothing but the source table. And after the source table, you write the names of the columns that you want in the square brackets. So I will start the square bracket and I will end the square bracket. These are my starting square brackets for projections to begin, and within which I will write the names of the columns in the square brackets for as many columns as I would want. So my first column request was sales rep, so I will write sales rep. This was anyways hard-coded, so there's no difference. And the second column was amount, right? And if I now press enter, you can see that I still get a table. It's not a list, it's a table, and within which I get these two columns that are requested for. Now let's just kind of do the error once again. If I go back and if I happen to delete the sales rep column, I delete it. Now the sales rep column is requested again in the form of projections in the next step. Sure enough, this is going to give you an error, of course. But because you have used the column referencing, right now, if you notice, the difference is that in the initial query, the names of the columns were hard-coded like this. But right now, this is reference of the column. It's not hard-coding of the column, it's reference of the column. Whenever you have a reference of the column, you can use a special character, which is a question mark. And the question mark simply means that whatever you are referencing, if not found, I will make a null column for that or a null value for that. If I now press enter, the query doesn't break. Sure enough, you get the null column for it. And if you want to work ahead, you can work ahead of this, but the query is not going to break. So this is the power of using projections and question marks together so that your query sustains through these little things that often break your query. So that was my first trick.
Yeah, that's a good one, of course. I always find the projection term, that's a Microsoft term, is such a big word for just adding a few
Such a small thing, yeah. That's right.
But yeah, the question mark, yeah, makes me wonder. For your next trick, maybe you're going to talk about two question marks.
I will probably.
Yeah. Because there's something to say about that too. That's a good one. Need to remember that one. So you see the file we left off. I'm going to return to that for another trick. But first I want to continue as part 2 of my first trick. I'm going to come out and I'm going to go to this thing, another file. As an extension to the previous trick, I'm going to use the same concept, but in such a context where I say I need it. I cannot just simply do a join time. This is the file where he said, okay, I'm going to do workouts based on an app with virtual reality. And he's got quick workouts here and then full workouts. Now, what does it do? You have to move on the rhythm of songs. Quick workouts, 2 songs, full workouts, more songs. And he wanted to know, oh, I like those 2 songs, that quick workout. Maybe I like the larger playlist that contains the same song. How do I match that? I have the quick workout table right here. He gave that, and it's the granularity is on the song level. So you have a track 1, 2, 1, 2, 1, 2. These are the quick workouts. And the songs are at the end here. Artist, pipe, title of the song. I've highlighted here a very interesting thing, cocaine, and then the next song in that workout is All Right Now. I do not approve of the message. Now, it's a slow and then a quicker song, of course. That's what it does. All right. Now, that's 1,100 something songs in this list. He also provided the full workout list. There's 10,000 songs in all of that. Same thing at the end here. And we have workout IDs, of course. And you want to match, what are the matching workout IDs? How do you solve that? That was his problem. It was a bit of a challenge video. And of course, as you might imagine, I'm going to solve it in Power Query. So what do? I load load the first table and I wrap that first table, quick workouts, I wrap that in a table group. I group by workout ID. I do the same for the full workout. I load the table, I group it by workout ID, but I do something else. I buffer. Now I'm being naughty here because the full workout table is the larger of the two. So I'm actually buffering the larger of the two tables. So it is good practice, best practice to buffer the smallest of the two, but the larger one here, it is small enough to fit in memory, so it doesn't matter. And it saves me a few steps in the process. That's why I did it that way. And here we get the trick, which is just a rehashing of the same concept previously. But this time I need the full formula. Table add column, new column each. And then I say, okay, I'm going to use table select rows on the inside. So I use what I like to call a mini let, outer equals current row data, which is this column here. And I need that little list. That little list has two songs in this configuration, as you can see. And I'm going to say table select rows starting from the full workout table. And this is my matching function. Each and then a very short formula. List contains all. The meaning, the current row data, now that refers to the inner table, of course, because the first each keyword is right there. Full workout. So take the larger list and it has to contain all of the items in the outer, and that is the smallest. This is the smallest, and these I extract the workout ID from the full playlist because that's what I'm interested in. But this little matching thing is right there. List contains all. Perhaps we can do this using the user interface and kneading and transforming the tables. We don't have to do that. This is all you need to do. List contains all. The Power Query has the right function for me. If we would do 5 tricks, I would have taken both tricks in the same one because it's just a reiteration. But I believe this you can't do, well, not that easily anyway, using the big gun functions.
And in the next steps, you just extract the values of the
yes, that is good to mention that. Of course, I don't want to see the list. I want to see the numbers of the workout IDs of the full playlist as I transform into text and combine it with a little comma space. These are regular steps. I throw away this data column. I don't need it anymore. I rename this quick workout, full workout, and this is the end result. How do you match things like that? You have to simulate this or do some fancy tricks in Excel grid formulas. It's just a list contains all thing.
These things also help understand that when you're working in Power BI and you have a very complicated nested requirement of matching two tables, multiple tables, how much can you simplify that using like the data model itself? How much can you simplify that using Power Query functions and these custom joining of the tables and stuff? So yeah.
Yes. So that was, let's say, part B of my first trick, but here it was necessary. Necessary to do it this way if you want to keep it simple. Maybe there's a workaround, very complex. We don't need that.
Yes, absolutely.
Makes me happy.
This is awesome. All right, we've looked at one question mark. Now we're going to take a look at two question marks, like I obviously said it. So I've got this simple table right here. We have months, we have units, and we have the price. Now, for some weird reason, whenever you are selling just one unit, the number appears to be null. So technically, I want to calculate the sales right here, and that is going to be the multiplication of the units into price. But the problem is, if you multiply null with the price, you are going to actually get a null value. So if you add a column and make a custom column, you either have to first replace the null values here with a 1 here. That means transform all the null values to a 1. Or if you don't do that, you will probably have to write an if function here so that it treats the null as a 1 and then does the work. If you were to write an if function, the if function is going to look something like this. So if the units is equals to a null, then 1, else the units column itself. And if you do that, this actually gives you the column, which is all the units which are produced correctly. And then you can take the value and multiply it with this particular value. But if you take a look at the formula, this is a large, gigantic formula, which is right here. Now, the thing is that what you can do, especially if you're trying to compare against a null value, you can use a double question mark, meaning something like this. I'm going to get rid of this column and create one more column again. So I'm going to go something like this, and I'm going to say, hey, why don't you take the units and write a double question mark after that? A double question mark means test it for a null value. Is it null or not? And if it is null, then I want to write 1. Now, this part is all of that if logic combined in simple, just like 2 letters, 2 characters kind of thing. So double question mark, test for a null. If it's a null, give me a 1. If I click on OK, it gives me the same result as I would expect. And I can then multiply that with the formula, which is nothing but my price. And that is going to give me my sales value. And we are kind of good to go. And that's my sales. So the double question mark especially works when you have to test it against the null value. Very, very helpful. There are a lot of times when people want to test it against null values, and that's where we can use that double question mark trick. That's what I had.
Don't tell me your next trick is going to be with 3 question marks, because I don't believe complicated.
There could be with 3 question marks as well, but the 3 question marks trick is going to be like, I'm just adding, this is an impromptu session, which I did not plan for, but it could be something like this. So if for some instance, the units column is deleted from here, then I can go ahead and say, hey, the units column is not found, and I can write a single question mark, and the units column is going to appear like it's there in the add columns tab. It is now able to read the units column in its mind. It's not visibly shown here. And because all of that column is returning a null value as we saw it initially, all of that null is converting to a 1 and then giving you sales, which obviously is not right at the moment. But hey, if you literally wanted to use 3 question marks, that's your trick for now. But this is not what I intended. But of course, you can use that. There is not a 4th question mark trick coming after that.
Okay.
So.
It was okay. It was okay. That was a quick response right there. Congratulations. You win this one hands down. That was beautiful, man. I'm going to go back to the previous context because in order to finish up this blue table, I need to add 3 more columns to the table. All right. Titles are in Dutch. That's okay. The fact of the matter is, this is the easiest of the 4 tables that I construct here, which demonstrate the purpose. The first column is a fixed, hard-coded. It has 2 values in it. I'm going to say it in Dutch, vak and vek. That's what the business wants, the business gets. And I need a date and an amount number. Don't worry, business, all of this is randomized. We were not installing solar panels in 1939. That would be ridiculous. And I need to add 3 columns to a table. Now, you know where this is going, Chandeep, because we all know the Chandeep trick. You need to add 3 columns, just create a record, expand it, and you're done.
Expand it. That's right.
Now, I say, let's take it to the next level. I mean, add a record, why stop there? Yeah? I'm going to add a little table. But then the column types, the data types, how can I retain that? But I believe it was in a previous challenge video with Rick de Groot. Yeah? And he showed create a list of dates and then type list of dates. And I thought, that's a beautiful thing right there. But you know what? Why stop there? Let's take that to the next level, combine those 2 tricks, and we're good to go. Now, you can imagine I could create a VAC sub table and do everything I need to do there. I repeat it in the same query with the VAC table and then make sure the names of the columns are the same. And I can combine those tables and imagine the number of steps you need. Here it's going to be just 2 steps. All right. So how do we do that? Where's that? Yes, a couple of queries that still work. Anyway, where did I leave off? Right here. Just a second. Now, making the table, I filter some conditions here. I just filter the rows. Not very interesting. Okay. And here comes the first, I'm going to make my little thing and then I'm going to expand it. And this is the complete, it's a bit of a formula, but it's a simple formula. I say table add column to filter rows where I left off the previous step by the name of data. That's the new column each. And then I say, I'm going to add, I like to call this a table literal. I'm making a little table. And the business saw the little table. 3 columns, 3 headers. They understood. And I'm going to add in that little table 2 records. And for this blue table, all I need to do is reference some existing columns. I have so many, I just need to reference the right columns. They wanted particular columns. I said, are you sure you want that? Yes. And you know what the business wants, the business gets. There are a few question marks here. Now I know what this means. That is my little table. Not just a record, Chandeep, sorry, but an entire table. Now, for the data types, I'm going to use a generalized Rick de Groot trick. I'm going to use a table type. As an optional argument in table add column, I can put it in. And this is what it is. Now, the question is, how can we learn what the table type, what the syntax is? Well, my suggestion there is the following. We've all used group by, right? And when you keep all the rows, that's one of the options you have there. Press enter, look at the formula, you'll see a table type. From that, I learned, that's the syntax. I can recycle that, and that's how I got this little formula for the type. Now, you can imagine what will happen. The next thing is I expand on the data column, and like a little parachute, the table will expand both column-wise and row-wise.
And brilliant. Can we just peek inside the table before expanding it?
It's a hard-coded table. I hard-coded some column headers. I have something to say about that, by the way. And it's so consistent. It's always the same layout, of course. 2 things. Because it is consistent, in the next step, I can simplify some stuff. You'll see it in a second. There is a bit of a caveat here. Table type, I put in as the optional argument for table add column. You can define the table using the table function and put the table type as the first argument instead of the...
Yes.
And then you might be inclined to think I can leave the last argument at the bottom here, I can leave it out. No, it won't retain the column types. That's my experience. And so no, I have to keep it like this. And because that first line line, I can simplify. I mean, the table type does not add any value to me. I simplify it to just the strings. And so you have to write it like this, is my experience. But that's okay. I'm not going to put it twice. That is redundant. But this is how you do it. And it's so simple because there's no splitting the beams of the query and then combining it back again, just like this. And again, the business understood exactly what they saw because they see the little table right there. Expand and you're done. Now, to finish off this table story, I do a first drop, but this is the final drop actually. I have a list dropping the columns I don't want in my output. Remove columns. I have a list for that. Sort rows, sort columns. Not even going to show that. That's default. And then I just put in a dummy step set. So we are done. Perhaps one thing, and it's a bit of foreshadowing, of course, otherwise I wouldn't say it. In these lists that I use to do stuff, these are generic formulas, of course. And that is foreshadowing for the next trick or something. The very next trick, I have a big table, more than 50 columns, but I don't hard code column names of those tables. They are not hard coded. So that's some foreshadowing for the next trick. How do you do that? But here it is, generalized Chandeep, Rick de Groot combo trick. And it's so short, it's only 2 steps.
Awesome. That was nice. In the formula bar up on the top, I've got a folder path that is C, users, PC, and desktop. The by default formula that Power Query uses to get data from the folder is folder.files function. So if I were to go and make a new query, so if I just say home, and if I say a new source from file from a folder, and I stick that path inside right here, press enter, and I click on open, you're going to see that it obviously creates a new query. And if I click on transform data, the formula that this uses is folder.files. Now what happens is that if I just maybe go to the far right of this query, there is going to be a column called folder path. Now this folder path initially is going to show the very folder which is listed right here, but it is also going to show me every single subfolder in that folder. So if I just maybe do the drop down here, and if I take a look at every single subfolder is mentioned right here as well. That means that the files which are binaries on the extreme left of the query right here, if you are doing any kind of transformation, it is not going to be applied to the very folder, but also the subfolders which are right here. I mean, they are somewhere at the bottom. And this can potentially increase the size or the processing of the query and can cause your queries to kind of have higher load times and stuff. What can we do about it? Now, if you were to just change that folder.files, which comes by default, to folder.contents, I press enter, nothing changes. It's still the same. But if you take a look at the far right, you're going to see that it now reads the very exact folder and not the subfolders within it. So if I just maybe go right here and I take a look, there are no subfolders within that folder. It just reads that very folder, and the number of files that you're working with is far lesser as compared to what they were initially. So this is just like a slightest performance trick to just limit what you're seeing on the screen and not go to the subfolders. Although Power Query inherently produces the subfolders and the folders within that, but this is a very, very good way to kind of restrict to what you are just referring to and not the subfolders within that. So that was my little trick right there.
The final time, I believe, for this file, if I look at those tables, for instance, DML, it's got like, it stops at BL column. So there's a lot of columns there. How do you manage stuff? I have this analogy I'm going to show you, bringing that in. This is a data model, the working stuff I use, but I'm going to focus on one such instance. This is, of course, you recognize it, the diagram view in Power Pivot. I'm going to zoom in on one such table. In this view, such a rectangle, the title is the name of the table, and the rows, the items, the rows in the table here are actually the column names of the data table. The concept I want to convey here is if I have a large data table and I want to keep it under control, I'm going to make a corresponding design version of the table. I have several, but we're just going to look at this blue one here, which is DML table, but then as you can see on top here, the DML design. So this is manual. I do manually enter all the column names. It's 63 columns in total in this case. I do look up from the real data table the exact names of the data table with a dynamic array. And if I were to do something bad, change something in here, it will be highlighted. So I added some logic and conditional formatting. Okay, right. So I'll undo that. So I can, if business were to change the title of data table somewhere or a column in the data table, I will notice it here. Again, they can't see this, so they don't touch this. This is the extension, the equivalent of what we saw in the data model. We used these 3 columns. Well, the third one is empty. I optimized it, so we only used 2 columns. When I said keep relevant columns, this is where I define in this here column. This is where I define keep those columns. So that is that. Drop some columns after afterwards, I say drop in just a sec. I load this table, and the column headers for this table, I will hard code. The values in these columns, I will hard code. But that is in back office. Nobody sees that. And I get column names from the data table from this column. So that explains how I got that particular information, those lists. I'll show you them in a sec. I'm going to go right ahead here and open this one up. Some people say they add some labels to the names of the columns to know what transformation they need to do. If it is complex like this, such a large table, I just put it in a corresponding design table and I match it up right here. I have that information here and I can use it. I even use, because this is not visible to the business, I find this useful to use this notation for the data types. So that is that as well.
Is there a data validation that you apply to the data type column to select what data type do you want?
Well, I was a little bit lazy. You could add that clearly, but when I do like this,
Alt down arrow.
Alt down will give it to me.
Nice.
Let me show you in Power Query how that works. Now, I'm going to show you DML headers is what we used, but it's quite a long thing. I'm going to show you DOV headers. It's a little shorter, but it's the same thing. So I load my DOV design table here. I do some projection. So I get a selection there. No question marks asked. I do some transformation and then I say, okay, get me those cat calls lists. There's the list. It's a bit big now. Cat calls, type list, and all the other stuff. And here I do your Chandeep trick where I put it all into a record. That is what I do here. But I'm going to explain cat calls list here. What do? I load my design table and all I do is give me all the columns that I consider category columns. List contains, I think I read that in a book somewhere. I think it's in your book how to do this kind of list contains thing. Ka-ching. From the key column, get me the headers from, in this case, the OV table. And then I have an exact list of all the category columns. And if I have that, I can say, okay, filter those columns, things like that. So that is build up to the next trick, if you like. I think this is really useful because the headers, these headers here, they are never hard coded in my M code. And that for me, it reduces the amount of text in the code tremendously. And I can manage it completely outside of Power Query. And that it's the elimination of a nightmare in my experience, actually. So that's what I like to do. If you have a big table, maybe you want to consider using corresponding design table. Now, selecting columns is one thing for filtering, for throwing them away, whatever. And this is another thing. I can also make so-called change type. There's type lists, I call it. But that is the next trick I'll show you.
I think people are going to be interested in taking a look at how did you take the text, which is a data type, and convert it into an actual data type. So
thank you for adding to my foreshadowing.
This trick is quite interesting that I have got for you. Imagine a 2-columnar table, which is just like column 1 and column 2. And if you take a look at column 2, I'd like to split this into 2 columns. So C is going to be here, and F is going to be here, and then T is going to be here, and then J, and this is going to be 1, F, and 3. So split into multiple columns. Now you can do that very easily using right-click and split by a delimiter, and delimiter is going to be a comma. You can do that. A lot of people know that. But the only challenge with that is that if I do that, I am going to hard code this query to just create 3 columns because here it's creating 3 columns at the moment. So if this query changes to 4 columns later, the query will not automatically update to 4 columns. Now, there have been multiple videos on how to do that, but I'm going to show you a trick that will blow most people out. So if you have understood the problem, let's go on an uncharted territory and completely different function that initially is going to look like no relation to what we are discussing at the moment. No relation. We're going to come back to it and kind of form a relation and solve the problem with that very function. So after you've taken a look at this problem, consider a completely different problem altogether. So in the custom 1 step, I made a list and the list has got 3 values. It has A, it has B, and it has C. Once you have a list, any kind of list in Power Query, in the transform tab up on the top, Power Query gives you the option to convert it into a table. You can do that. Why? Because when you're working with a list, the options are pretty much dead. So you can see that all of these options are dead, all of these options are dead, so on and so forth, because Power Query was natively built to work with tables and not a list. So sure enough, I'm going to come to the transform tab and click on from to table option. Let's just see what does it give. I click on to table. It gives me a bunch of options. Right now, I'll assume that I know nothing. So I'm going to click on OK, and this makes a table. So I had a list and the list was converted into a table in the next step. But now if I take a look at the M code, the M code says that the function that I'm choosing to apply is table.fromList. That's the function. And it does a bunch of extra things as well. Now, I'll show you a few things. Imagine that we have text values here, and because we have text values here, we can choose to delete most of these options right now. So I don't really want to split the values. I don't want these extra parameters. I don't have any extra values. So all of these optional parameters I will choose to remove, and I will just work with the vanilla function table.fromList. That means the previous step is a list. Please convert that into a table and render it right here. And the option doesn't change. The output doesn't change. It's still the very same output. People understand this. Now, let's just play a game. I'm going to go back to the previous step. And in the previous step, I will modify my list a little bit. What is the modification? The modification comes something like this. Now, instead of having 3 items in the list, I will just have 1 item in the list. Something like this. I will have A, comma, B, comma, C, and all of these 3 items are going to be in the first cell. So the way I write it is that, hey, I will start with A, I will then write B, and then I will write C. And you can see that because, let me just remove the extra spaces in here. So because I just have 1 single item in the list, it appears now as this list where you have A, B, and C. Now this list is now next fed into the table.fromList function, and see what happens. So if I go to the next step and take a look at table.fromList function, the table.fromList function is going to convert a 3-columnar table out of it. That means that the table.fromList function has somehow got this sense of taking a look at a standard delimiter as a comma, and wherever it sees the comma within the single item, it'll split right here, and because once it splits into multiple columns, not multiple rows, because these are not multiple items. This is a single item separated by a comma. It will split into multiple columns. Did you see that?
Yes.
1 item with 3 values with a comma split into 3 columns automatically. Now, even if I have, let's say, 4 columns here, A, B, C, and D, I am going to get 4 columns on the right. This is awesome. This gives me a hint that if I go to the source step and if I now take a look at this, perhaps I can do something very similar. Here, there is going to be a 2-columnar table, a 2-columnar table, and a dynamic 3-columnar table. I can do that because the by default separator is a comma. These are values, and I can do that. Let's just try to do that. I'm going to make a new step and again reference it back to the source step so that people can refer to this Excel file. Now, for clarity purposes, what I'm going to do is I'm going to create 1 additional column right here and have the values populated here so that you can compare between this and compare between this. So I'm going to go over to the Add Columns tab, make a custom column. Now, in the custom column, I'm going to write the formula that I used, which is table.fromList. I will start the bracket, and in the bracket, it says give me a list. I will feed column 2 and I will close the bracket and I'll click on OK. But this results in an error. Why? Because you referenced column 2 and the contents of column 2 are not a list. So unless you convert this into a list, this formula is not going to work. So if I just go back to my formula once again, and if I say that, hey, column 2 is going to be in a list, so I just kind of surround that within the curly brackets, like a pseudo list container that I'm creating. So I'm going to click on OK, and now this forms a table. Now, if you take a look at this table, 2 columns, take a look at this table, 2 columns, take a look at this particular table, 3 columns. And all that you do now is use a list to combine the 3 tables and you're off to the races. So there is no funky multiple steps involved. All that you're doing, because the table.fromList function has the native ability to split by a comma, you can use that to your advantage to split it by as many columns as you would want. And people have seen multiple times on YouTube and stuff that how do you dynamically combine these 3 tables without hard coding the column names. And there you have it. Like, you literally have the dynamic split by solution without hard coding anything.
Wow, very good. I learned new things here. I didn't know that behavior. And that was cool. That's one, actually it's a string, eh? And the comma in the string is interpreted as a column separator.
Yes.
I didn't know that. That opened some perspectives. All right, now my next trick, how to deal with complex tables and manage them. That was the previous thing. So final trick in this workbook, the catcalls type list as an example. Many instances of these. If I go back to the design table, I have a data type column indicating this here column in the data table has to have that data type, right? It's very simple. I expressly use the right capital letters and all that. So it's the right type written in the correct way. Why doesn't it work? And that's my initial problem. Why? Well, it's very simple, because it sees contents clearly as text. It's a declino data type. Here's the any type. Just like in Excel, it's outlined to the left. It's text. I said, no, I want you to see it as a type. How'd you do that? I got it all lined up here. Yeah? And I want to use this formulation here because I can make a difference between I can differentiate between percentages and integers and all that stuff. Well, I'll go to catcalls type list. Remember the table that you just saw? I filtered the category columns. It's only 24 columns. And I transform those headers into a change type list. And you know that is a list of lists, with the inner list is the name of the column. And then it says type here, but you have to trust me on this one. This preview subpane is only partial. It does say type text in this case. So it's really working. So how do I transform a list of column names into a change type list like this? I need my headers OV, that's the name of the columns, and I need to extract the data type column. So what do I do here? Add column by the name of types. Where is it? Types. On a filtered table. We did that before, so I'm not going to repeat that. Add the types column, and I say each. And then for each item in that list, I'm going to make a sublist. What is in the sublist? The name of the column itself, and then this little thing. A custom function. I'm not going to hover over it, spoiling the surprise. It's avax get type. And what do I put in? For the list, the current data type, but it's a text. We know that. I'm sounding like Win a little bit now. I'm excited. And in the end, I'm just going to extract the types column as a list. And this is what you see here, and that it's done. Now, the trick, of course, is in this avax get type thing. Exciting. So how does it work? And is it big, or can we make it smaller and easier? Well, of course we can. This is the get type. I put it in GD Guru. I'm sorry. I hope I don't offend you with that name. So this is it hides the information and it hides the logic. It's a single step function. Type is text is type. Well, that sounds funny when you see it. Yeah. And then I do type table, an exact match lookup, and then I get the type column back, and that's it. So in other words, I transform the type as text and I get back a type as type by doing exact row match lookup.
This is brilliant.
Oh, it gets even better, this. Yeah. By the way, you see my typical signature move, name equals name. I always do that because it's easy to manage. Type as text equals type as text. Quick explanation on how it works. Type as text in my lists. I forgot to mention that. I did that as well. And there I was going to say, okay, the left-hand side is the name of a column. That is true. And the right-hand side was the name of a step. But here we don't have any steps. So what is this right-hand side here? Well, it's nothing but the input variable type is text. So name equals name. I use it all the time. And this is just another proof for that. So that is that. It's an exact match row lookup. So all the complexity must be in that type table, right? Here it is. It's a table literal. I used to, but I don't use any data typing anymore for this table. It's unspecified. Just some column names. And I have two records on a row. Text.type, text.type. I made that table because I use the same trick here with delimiters or whatever. I look up the text, and this is definitely, you can see it here. It's a type. This is a text type, number type, etc. So I reduce that entire, transform the text version of a data type into a simple exact match lookup thing. I'm sorry if I disappointed you because it's not more complex than this.
No, it's actually pretty brilliant. So you captured all the types.
I can fill it in here, right? And then I had a conversation with Rick de Groot. Rick, chime in, will you? I had studied several pathways to the solution, but one was a dead end. Here is the one that doesn't work. I knew that. That's an even shorter formula, and I don't need the type table because we have expression.evaluate.
That's what I was thinking.
And then I mentioned that in a comment from some video from Rick, and he said, you could do that. I said, hey, that doesn't work because it does work, but yet then you have to use not text.type, but type space text, the other notation. But you have less options there. You can't use integers or percentages.
Yeah.
And he came back to me and he said, that's normal, but you can use what we just used, but they are not types. I'll ask you a little question. Is this a type to you?
Yeah. That's a type for me.
And Rick said, no, that's not a type. That's a facet.
I see.
And my first reaction, a little bit ironic, was, that is fascinating. That's not a type. No, that's not a type. It's a facet. Okay. But he says, you know what? If you add an additional optional argument to the expression.evaluate function, if you add the environment, then it will work with facets.
Yes.
And I thought, optional argument. And in the background, I was hearing Chandeep shouting, feed it what it eats. Come on, Chandeep. This is not a small child. We're feeding some okay, you're right. So if you do it like this, and I said, wait a minute, I know that environment. I know that's an environment. I use it all the time. If you add that little argument right there, this thing will work with facets. Forget about the type table. Exact match lookup. It works beautifully, but this is the fastest way. I responded to Rick because he closed the circle on that particular train of thought. I said, you have to make a video about that, man. I don't think you ever did, but I mean, I said, you have to do that, man. I mean, you close close the circle. I mean, I attribute this trick to you. This is, for me, it's a Rick de Groot trick because of that conversation. And this is the minimum implementation of how to change a typist text into a typist type. This one is beautiful. It's very powerful to me because I use it in my design tables and stuff. I use this all the time.
In fact, what you can take it a step further, I believe, and you can have formulas evaluated like this. So you can have pick and choice of the formulas, bring that in the expression.evaluate, and then depending upon what the formula is listed in the spreadsheet, in the control sheet, you can then run that formula as well. So I believe it can be used like this as well.
Okay, but in Power Query, assigning types is become trivial now. If you have that little setup with the design table, if for very big tables and stuff, I'm really excited with this one, and I incorporate it into my work clearly. I won't be showing this example anymore. I've exhausted it for all the stuff that's in there.
So a lot of people would have been asking me in their mind is that, hey, just a while ago when you were splitting the text by multiple delimiters, you were lucky that you had a comma here and a comma here and a comma everywhere. But what if you have to now split it with different characters? So you have a comma here, then you have a colon here, and so on and so forth. So how do you do that? Now, the table.fromList function allows you to have multiple delimiters as we saw it. So if I just maybe copy this, Control C, if I make a new step and I just feed that in a list right here. So that is my list. And press enter. Now, when I use the table.fromList function, you can see that it actually asks you for a list, and that's my list. And then it has a splitter function. Now, in the splitter function, I can use any kind of splitter function. And one of the splitter functions is split by any delimiter. And that's where I can provide multiple delimiters right here. So I can go something like splitter, split by any delimiter. Then I just have to provide a list of delimiters. So one of the delimiters happens to be a comma, a list of delimiters. So one of the delimiters has to be a comma. And the second delimiter is going to be a colon, and I'm going to close the bracket on that, and I'm going to close the bracket on that and press enter, and you can see that now we have T, J, and I. This thing, I can just copy it, like literally Control C on it, and I can just again reference to the source step. So source, press enter, and I can now add a new column. I can also modify the very column here, but I'm just adding a new column just to help you see the difference. So I can just paste the formula in here. This list is not going to be the hard-coded list. This list is going to be this particular column value. So I can just maybe delete that part, delete all of that, and a curly bracket in the, and within the curly bracket, I can feed column number 2, do that, and then we can click on OK, and then we have a table here. The table has got 3 columns. Here the table has got 3 columns, and here the table also has got 3 columns. But if you just go ahead and change this, if I just go and change the table right here, and if I say, hey, I now want to have another comma, then the letter L after that, I click on OK. Now this should have 4 columns. So if I go to the last step right here, this has got 4 columns, 3 columns, and then 3 columns. So it's dynamic that way. So the same solution is just that we have added the splitter function to split it by as many unique delimiters that we would want, and the solution is still dynamic, which is where you get n number of columns created by the number of delimiters that you have. So that's a little more robust solution.
It's another instance of feed it what it eats, of course, and use another argument. I guess I didn't know it until now that you could do that. I never practiced it anyway. So you can always substitute as a separate step and unify or make it uniform on the comma, and then use the thing. But this is a single step or single function solution where you use another argument.
For the reason that here you have a list, and at the moment the list is hard-coded, but you can use the ASCII characters or something to generate as many unique or special characters on the keyboard. So you can literally have all of them right here. So wherever you have like a special character, it just splits it on its own. So that will actually save you multiple replace steps within your query.
Yes, and you can actually put that list into a separate step.
Separate list, separate step, separate list, whatever.
Separate query, that's what I meant.
Yeah, separate query.
So the general applicability of this is clear. So that's a new file, a different file. And the trick is called, well, we've done exact match lookup, right? The context is this. I have a sales table. It's an Excel is fun example, as a matter of fact. But I have an entire sales table and I want to calculate the discount. And this is various solutions. I'm only going to talk about this one with the green background, how to calculate a lookup approximately corresponding discount value. Historically speaking, I mean, we can use a table select rows solution. Not even going to mention it. You can use the interface for that. We know how to do that. Historically speaking, apparently, I learned that there is this sorting fill down trick that was attributed to Os du Soleil. Os, leave us a comment. Have a few laughs. Don't worry, he's an American. He'll understand. I did a poor job at that. Anyway, so that is his trick. And it was known, and it was pointed out that's his trick. The thing is, I did some calculation times. It's not the fastest. In the context of Excel is fun, I did list accumulate, and it happened to be an efficient trick in terms of execution time. This is seconds, as I mentioned here, for 1,048,000, so it can at least have some calculation times. So that is good. And I thought of a few more ways to do it, list or generate, due to some comments, interaction, and then I came up with El Pozo. El Pozo clearly is derived from list position. Now we're going to use that. It's going to be super simple, as you can see. So I'm going to dive into Power Query. How does it work? All right, just like any good query, you start by, in this case, referencing the sales table, the fact table. Now I also have a discount table. This is that little table there on top. And I have to stress one thing. I need a safety record, meaning a record that catches everything in my discount table for El Pozo to work without exceptions. And I don't want to do any exception handling, keeping the formula as simple as possible. You'll see it's very simple. So in my discount table, normally I have the records on top, but I need a ridiculously high number, and the discount number is the same as the previous one. That is a very small effort to ask. So I have to be very transparent about it. You need to add that. Back to El Pozo. I'll use this one. I load my sales table. The next thing I do, I'm going to go and grab my discount table. We've done table buffer. I'm going to do a list buffer here. So I take the first column as a list and I buffer it. It's going to be on the inside of an iteration, so it's the buffer thing, keeping that concept. I'm going to do the same for the percentage column, extract it, buffer it as a list. Now these two lists are linked with a common index. You know, the sequence is the same. They correspond. They're columns from the same table. And then I have only one step left. We're already at the end of the query. Add the discount. Could it be in it? No, it's a very simple function. There it is. Table add column, source by the name of discount each. And then I'm going to do a lookup into a list, so the curly braces. And inside, I'm going to use list position off. Again, there's only one each keyword. I have a sales column here that refers to the source because it's linked to each. The same reasoning as in the first trick. List position off. The first argument is discount sales. But remember, discount sales is a list. If this were to be Excel Classic, Excel grid formula, I would say that's a dynamic array. But here it's a list. And then I say as a second argument, current row sales. Well, that's the current row in the outer context, and you see it right there. And I'm going to use list position off. The next argument I want to skip, that's a null. And then I'm going to close this so you can see it in one line. That's better. I have this, a custom function. Two arguments, a comma b goes to, and then a Boolean logic. A
just to check if it's less than equal to a or not. Yeah, that's brilliant.
And that's all I need from list position off. Now allow me to explain. A is an entire list, and I'm going to say right off the bat, this is my interpretation. I'm going to tell you in detail. I'm going to show you what you get from the help file, and then you'll know, yeah, you're going to have to add your own information. So I have a two variable selector function with A and B. A is the full list I'm going to iterate over using list position off, and sales is the value for each row in the outer context I'm going to check in order to extract the right value. And the condition here is B less than or equal A, and that's it. Now that means that the running value will be checked against that little list, and it will be not smaller. That's a false, and another false, and I will get an entire list of output internally in list position off. And at some point, I will get my final record, and that will trigger transition into true because I chose those values deliberately. So it's false, 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 true. Now the true may come sooner than the last record. The transition into true triggers the output. So the last, right before the transition, that is the position, the offset, the ranking number. That's important. It's a ranking number. That's the ranking number that will be the output of list position off. So because it's a ranking number and I use it as a lookup in another list and I need an index value, that is zero based. So I need to subtract one. And you can challenge the results. This is approximate lookup in one line.
Yes.
And it does exactly what it needs to do. And it is ever so slightly better than my list accumulate function in terms of performance. Now, why is this so an interpretation? Allow me to go to the general descriptions here and show you what lists position off. This is what you get. The last argument is equation criteria. criteria as any. It doesn't even say that it's a function, let alone a two-parameter function. It doesn't explain anything. And truth be told, I hope they don't mind, yesterday I looked it up in the book by Rick de Groot and his colleagues. Very big book, 700 pages. They don't mention list position off. I tried to find it, didn't find it. So yeah, it was trial and error perhaps, but I really wanted that list position off trick to work. And that is why I studied it a little bit, and I came up with this little formula right there. Just this little criterion matching function works beautifully.
So I just want to add two things for this formula to work for everybody watching this, which is the list, which Hertz is referring to, should be sorted in the ascending order for this to work. That's one. And number two is that the list.position of function by default returns the true value. So when he's writing the check b less than equal to a, it's going to constantly check that when does that condition become true. And as soon as it becomes true, it stops to do that check, returns that position number, and then we just strike off -1 from that to find what is the item's position in that particular list. And that item position is nothing but the discount percentage that is returned right here. So
yes, so it's I think it's super clean, super compact.
Super clean,
there is no sorting. Sorry, Oz, no offense. You're a good guy, but this is most efficient.
That's neat. That's clean. That's neat.
So there we have it.
Now, this is a very common scenario that I'm going to present, which a lot of people can relate to. So you have a two-columnar table right here, and the two-columnar table has got a column which has got nested tables. And if you want to combine the data off of these tables, you have a couple of options. You can convert this into a list and use the table.combine function. That's one. You can click on the expand button. The only caveat is that in that case, the names of the columns are going to be hard-coded, which you can get it through by using a list function and stuff like that. But there are a couple of workarounds. My need is that I want to expand these tables, like all of this. I want to expand the first table, the second table, and the third table. And I also want to retain the name column alongside. So eventually, I will get a single table with all of the columns right here and this column as well. One of the ways to do that is to use table.fromPartitions function. So I can say something like table.fromPartitions. So the table.fromPartitions function, what you do is you write the column value as text, whatever text column that you would want. And then the partitions need to be in the form of a list, a nested list. So I'll show you how that works. So I'll say table.fromPartitions. I'm going to say that the column that I'm trying to create is the file name column. That is the extra column that I would want. And then I would want to have a nested list. In the nested list, you're going to have the value and the table, the value and the table, so on and so forth. So if I just go right here, and if I were trying to convert this particular table into a nested list, I'm going to use the function table.toRows function. So let me just delete that for a quick second and show you table.toRows function, two rows. And the table.toRows function refers back to the table, which is there in the previous step, tables in the previous step, press enter. And every single row right here has been converted into a list. The second row has been converted into a list, and the third row is also converted into a list. So if you just take a look at this list right here, this is the first value and the table, the second value in the table, so on and so forth. Now, if I bring back my table.fromPartitions function, the second input is the function that I just pasted right here. What this is going to do is, this is going to take every single value and the table, combine it, and the extra column is going to be called as the file name column. Take a look. So we have the file name column, the column that we just mentioned it right here, and all the tables are combined, which is a nested list. So you don't really have to do any kind of expansion, any kind of extra extraction of the list, nothing of that sort. You can just use the table.fromPartitions function. And a big shout out to Rick de Groot for showing this trick.
You made a video about this, didn't you?
Rick actually came on to our previous Power Query battles, and I believe he showed it over there.
Yes, I've seen it before in that context, but it's again, it's like a single step solution to something
very, very common. Yeah.
And it's very common. You need it. So is it complex? No, it's not complex. Do this and use the right arguments again. Feed it what it eats. If you feed it the right stuff, this comes out. It's so beautiful.
I can take it to the next level also. I mean, I'm just discussing it.
You mean 3 question marks? Pardon.
No. So at the moment, if you think about it, we've got these two items in the list, and this could be a nested list item as well. So right now, this is February. This could be a nested list items as well, or this could be a record also. So till the time you have a single value here that denotes the particular table. So you have Feb and you have one additional item here that could be any item. You have Jan and you have one additional item that could be any item. You could literally use the same function that works like this, and here you will have the nested list appearing alongside, and then you can expand it further, do more work with the tables and things like that. So the sky is the limit, but I'm just like discussing the possibilities of this.
Nice. As a final trick, I'm going to do something live in the sense that I'm going to do it by typing things, because I've shown steps and maybe people think I can't write my own code, something like that. And I'm going to turn it around in the sense that we use Power Query to do data reduction. Now I'm going to say, why not generate data from scratch in Power Query? Some stuff you may want to have at some point, and the Python boys and girls are going to say, we have a library for that, but we don't have it in Power Query. So what is it? The context is to generate arrangements. Now, arrangements in the mathematical term, meaning combinations, permutations, things like that. I'm not going to count them because we have standard functions for that. If you want to try all the combinations, you're going to need all the combinations. All right. So I'm going to give a little table of contents here. I'm going to start with a template. I'm going to make it easy on myself. Copy that little thing. Then I'm going to say all, right, because I want to generate all of them. Repeat variations. Then I want combinations, permutations. It's a generic way of doing this, so we're not limited to just one type of arrangement. And as an encore, I'm going to give you the arrangements. I'm going to clear my buffer and set these names in the buffer for reasons of efficiency. All derangements, all permutations, I think I spelled that right, all combinations, all repeat variations, and we'll start things off with the templates. Okay, so that's a table of contents. I'll just delete that. We don't need it anymore. Toggle this, and we're going to start a new query in the blank sheet right there. So that is that. So the first thing I'm going to do is generate all templates, make it bigger here, start writing my templates. All right. Now it's very easy because it's a single step function. I'll define it formally and as a number, because you know there's two parameters. Result as a table goes to the function itself, single step function. List or accumulate. I'll make a table, so I'll iterate over the columns to k, because the first column is seeded. That's the second argument is a seed, apparently. Table from columns. The seed list is the full list from 1 to n, and we will call this column 1. Okay. Then the usual suspects in list or accumulate. So I call mine state, I goes to, and here I need a mini let for header, and it's text from I. You know how picky Power Query is. In what's my calculation? A double wrapper. The first one, inside out, table add column to the state variable, add a column by the name of whatever is header, and then I say each. This is the field formula. This is the field list, same list, 1 to n. The next function out right there, I need header as well, and that function is table expand list column. So that's creating the function on the quick. I'm gonna test whether it works or not. We can do that using the interface. As you can see, I put in some parameters. N is 10, k is equal to 4, and I get a table. I'm gonna rename it on the quick. This is just a template. All right. I can look here. There's a overflow. It works beautifully. I'm gonna go back. I'm gonna fight the interface a little bit because this is what I wrote. And if I go to the advanced editor, he put in some stuff. I don't need that. I just need a single step function. If I do that, it cleans up the step. Good to go. There's only one step, so there's no need for variable.
For the let.
All right. So that is that. Works beautifully. From now on end, the hard work is done. I'm going to recycle my template. Okay. Now again, what does it do? I will iterate. I'll start making a table from column, put a list there, and that is the first column. And then I will add each row of that one column table. I will add, where is it? I will add the same list for every row, and I will expand it again. And that is what we see here after expansion, 4 times, 3 expansions, because the first one was there, and it works beautifully. All right, so the first one, from now on end, it's recycling is the name of the game. I'll duplicate this, and I'm going to call it, I buffered it, repeat variations. Variations with repetition, I call it repeat variations for short. I'll stick to this name right here. Now, it's very easy. I only need to change the lists. So I'm going to shift it down 1 unit. There's the other one right there, and I'm done. Testing, change the name real quick. And if you look at these numbers, they're in a table format, but if you look at these numbers, these are all the numbers that we know from 0 all the way up to 4 times 9. So the numbers we use every day, they are repeat variations. Who knew? And we all know that. N here equal to 10 is called the base. And you saw me modify the formula. All the digits vary from 0 to n minus 1. K here equal to 4 is called the number of digits. So it's very, very simple. This is repeat variations, a very large class of arrangements. So that is not very exciting, I suppose. Let's go for the next one. The next one down the list was combinations. I'm going to modify my little query here. I'm not going to modify the function as such. I need to modify the lists. So I'm going to say n minus k plus 1 right there, which generalizes to n minus k plus I over there. And I need to change the lower boundary. I need to get the value from the previous column, whatever it is, and add 1. That's the starting position for that. So what do? I take, it's a little bit split here. I take the current record and I say record to list, and I should wrap it again and say list.last. You see that? List.last, record to list. So that's how you take whatever you have the last on the same row. So that is
common thing in list accumulate.
So I'll test it again, change the name real quick. Combinations 10 4x4. I have, as you can see down here, 210 rows. You can check it. It works out fine. It starts with 1, 2, 3, 4, and it ends all the way down. If you scroll down with 7, 8, 9, 10. This is all the combinations, 210 in total, just like that. Now this is generating only all possible combinations, 10 4x4, nothing else, single step function. It's a direct generating method. Generate them and done. So who needs Python libraries anyway if you have this? Okay, now let's go for 2 more to go. Permutations. You're going to be surprised for this one. This is the template. I just duplicated it again. All I'm going to do here is take the lists in the field side of things, so the repeating one. I'm going to say take the current record and remove duplication. So take the current record to list, and then I say list diff. So I take the full list, remove what I already have on the row, and that's what I want to keep. And for some reason, that's a little funny, this yields permutation. I'm going to give a very simple symmetric case, and 4, you'll see why in a sec, and there's only 24 records here. You can see that. So it starts its permutations, so change the name real quick to keep my queries nice and tidy. 24 records, it starts with 1, 2, 3, 4, and being permutations, of course, it ends in 4, 3, 2, 1.
I think it can be pretty useful for manufacturing setup where you're trying to match the machines and the goods produced in different permutation combinations of machine item and product code number and things like that. So I believe where you have to build a roster or a schedule to take a look at all the permutation combinations of machines, and this can be like really very useful over there.
Yes, I mean, in high school and everything, we studied counting these things, but they said we're not going to generate them. Well, that's exactly what we're doing here. If you need to check all possible combinations or permutations, well, it's a single step function. It doesn't get any quicker than this. There's no special stuff. There's just one step. We can do it ourselves in Power Query. Now, as an encore, it's a lesser known type of arrangements. I'm going to talk about derangements. Now, what are derangements? Derangements are a special type of permutations where the initial position, as we can see here in the headers, must change for each column. So 1 cannot go to column 1, 2 cannot go to column 2, etc. This is a little bit more tricky. So just to be on the complete side, I'll duplicate permutations function, rename it on the quick. Not permutations here. We're going to name it derangements. So it's permutations, but everything has to change. The initial position must not be there. It means that the first column cannot start from 1, so it starts from 2. It's not difficult at all, is it? And I need to remove the I like to call it the index. I need to remove that as well. So I think it's like that. Let's test it on the quick. The same symmetric solution. You'll see why I need that right now. So that is that. We're not quite finished. We need to add one more touch. Change the name on the quick. Derangements. Everything is deranged. Everything is offset. Even less options here. There's only 11. Well, the thing is, if I have the symmetric case where case equal to n, in the symmetric case, in the last column, I get nulls. I need to filter them out. That's the complication. Yes, but I can't do it on, hard coding in column 4. Not to worry. I'm going to recycle a bit of code I wrote earlier. Where is it? That's list last trick record. Just going to put it in right there. And this is the generic formula for remove nulls from the last column. Now I'm going to make it beautiful in the sense that I'm going to copy this, exit out here, and on the quick, I'm going to integrate it. Let loop equals all of this in, paste, link it up to loop, and that's how you do that. I mean, it's one of the ways you can do that. I just no extra steps in my check here, and it is done. That is that. There's a little bit of filtering in the last column going on, but apart from that, everything else is direct generation. There is no iteration except for the construction of the thing. Now, on the quick, allow me, because people think, wait, 9 such arrangements, they are few and far between. Let me parameterize this, if that's a word, on the quick, let Ola. And so this is that. You can make it underwhelming.
3 and 3. Nice.
You can say 5. That's more like it. Now, the thing of this preview pane here is limited to the first 50 rows. As you know, it will expand automatically when you scroll down. I want to make sure everything is generated. And in order to do that, I'm going to return to 4, just like that. In order to force the generation of all the derangements in this case, I'm going to do something controversial. I'm going to count them. Table row count right there. And I get 9. Now, they are few and far between, but they grow large in number quickly. If I put p equal to number, to 10, then it's going to take a few seconds, twice as long when you're in a video call. This is very inefficient to do that. Generate all of them and count them. There's a closed form formula for that. In this case, involving covering the Euler constant, I believe, but that's a different topic, and normally it's finished by now. There it is. It just generated a good 1.3 million records. So it's not that bad. I mean, in terms of performance, I think it's quite reasonable, and it just simply does that. And there's an advantage with compared to Excel. It's more than what you can fit on one sheet. Power Query doesn't have that problem. By the way, as a little extra, you could load that entire table back into Excel, but you'd have to do that into the pivot table cache. You do know, of course, that
or into the data model.
In the data model, sky's the limit. But you could actually do that. I've done that in the past because, standard pivot tables, you have grouping, and you lose that in Power Pivot Table. And I wanted to have a histogram. So I loaded back into the standard pivot table cache. You can load very big tables in there. The file size will be according, of course, but it works beautifully, by the way. So we have options here, and Power Query does that. By the way, my options in Power Query are such that when I say close and load, I load everything as a connection only, so that's quick and snappy. I can pick it up from here. You see, generating combinations, permutations, they have no more secrets for us anymore.
Awesome. I'm not sure if I can match your last trick, but I have something, simple one, but quite often needed. I've got a 2-columnar table. We have a category and we have the feedback. The feedback can be excellent, bad, or average, the 3 kinds of feedback, and I want to sort it. But the 2 standard sorting available options are sort ascending or sort descending. If I do either one of them, the sorting order is going to be alphabetical, not custom sorting order. But I would want to have excellent first, then I would like to have average after that, and then I'd like to have bad after that. So that's the order that I would want. Now that's a custom sorting order. How do I do that? Now, what you have to think about is that you can literally use the table.sort function that just came in a while ago right here in the formula tab. But then you can, in the formula bar, if you're able to generate a unique value for every single value. So let's just say if I can generate 1 for excellent, 2 for average, and 3 for bad, then I'm sorted. I can literally do that. Right now, there are just 3 values. So I might as well write an if condition just to kind of show you that how can you do that. So I can just go ahead and say something like, hey, I am trying to do sorting. So table.sort, that's the function that Power Query used by default. The table on which I would like to apply sorting is source. That's what I have. And once I have the table mentioned right here, then the comparison criteria comes in. Now I can, in the curly brackets, write my sorting criteria. So I can go something like, I can say each, and I can say if the feedback column, the column that I'm trying to fetch feedback, is equals to, let's say, excellent, and I'm going to hard code this for just a second, then I would want the value to be 1. Else I can just check again. If the feedback column is equals to, let's say, average, AVG, then this is going to be 2. Else it's going to be 3. Just have 3 values, close the bracket and press enter, and this works fine. You can see that we have excellent first, we have average second, and then we have bad after that. Now what I have done literally is that I have taken the unique values from this column, excellent, average, and bad, hard coded them in my formula, and I have assigned a number to every single one of them, and the standard ordering of sorter is ascending order, so descending order, and then we have 1, 2, and 3, and the sorting order is done. Now this is not very scalable. The problem is that you can't be if there are like 3, 4, 5, 7, 8 values, you can't be feeding in the values manually like this. So we need something more dynamic. So to be able to do that, I'm going to use the list.positions of function.
Yes.
So I'm going to say, hey, each, and I'm going to say list.positions of, I'm going to start the bracket, and it asks me for a list. And this list can be a hard-coded list, and you can bring that through Excel. You can type the list out, but this is still scalable as compared to hard coding every single value. So I'm going to feed in the 3 values, which is a list. So I just do the curly bracket. So this is the first one is excellent. Now note that in the list.position of, when I'm writing the list, the order in which I write the items matter, because that's the order what is going to be checked. So excellent, the second item is average, and the third item is bad. And then I close the bracket. And then the value that I'm trying to check for comes from this column, which is the feedback column. So I can just maybe do, hey, the value that I'm trying to check for is nothing but the feedback column. List.position of, bracket close here, and then this should work just fine. And then we can have the sorting criteria done. Now you can scale this as much as you would want. So at the moment, this is excellent, average, and bad, but consider if these were months. Months can be generated on the fly using formulas in Power Query. So if you have a hard-coded custom list, you can bring that list from Excel and then have it compared like this. But if you would want to just maybe type out a list, that is still also doable. But then this is a way to kind of custom sort it in your own particular way to do that. There's no need of creating creating an additional column and then sorting it and then deleting that column. You can do that all within the table.sort function. So that was my last trick. All right, that was an interesting one. Geert, thank you for this. I hope you enjoyed it as much as I did, and I hope that people are going to enjoy this as much as we did making this video. Please do not forget to drop in a comment as to which trick did you find the best one, and we shall see the results very soon. Thanks for coming.
Thank you.